Every once in a while, we ask big, terrifying questions. What would happen if we detonated the most powerful nuclear bomb ever created at the deepest point in the ocean? Would it trigger massive tsunamis that wipe out coastal cities? Would it set off earthquakes, level countries, or even crack the Earth's crust? Would it disrupt the planet's orbit? The answer might surprise you. The Mariana Trench is the deepest known point on Earth. Located in the Pacific Ocean, it plunges 11 kilometers, or nearly 7 miles straight down. That's almost 3 times deeper than the resting place of the Titanic. It's pitch black, crushingly pressurized, and almost untouched by humans, a perfect place for our hypothetical nuclear test. For this experiment, we'll use the Tsar Bomba, the most powerful nuclear weapon ever detonated. This Soviet hydrogen bomb released the energy of 50 million tons of TNT, sending shockwaves around the world multiple times. Its mushroom cloud climbed 56 kilometers into the sky, and its fireball alone could have engulfed an entire city. So, what happens when we set it off at the bottom of the Mariana Trench? First, the detonation. The moment the bomb goes off, the darkness of the trench is shattered by a blinding flash of light. In an instant, a massive fireball forms, vaporizing everything in the immediate vicinity, including unfortunate deep-sea creatures that never saw it coming. A superheated bubble of water, radioactive debris, and nuclear energy expands at a furious speed. But unlike an airburst, where the explosion can grow unhindered, the Mariana Trench has a problem: 11 kilometers of crushing water pressure. The immense force of the ocean squeezes the explosion, preventing it from expanding as much as it would on land. Instead of a massive mushroom cloud reaching the heavens, the fireball bubble reaches about 1 kilometer in diameter before the ocean fights back. It starts to shrink, oscillating in size like a balloon being inflated and deflated over and over, until finally, the water wins. With the fireball extinguished, the energy of the explosion is absorbed into the ocean, sending powerful shock waves through the water. Seismic stations around the world detect the tremors, and nearby marine life might not be so lucky. But does this unleash a chain reaction of destruction? No, not really. Despite the violent energy release, there's no apocalyptic tsunami. The ocean absorbs most of the shock, reducing it to little more than a churning disturbance on the surface. Ships and marine animals in the immediate area would have a very bad time, but for most of the world, it would go unnoticed. The tsunami risk? Minimal. So what about earthquakes? After all, the Mariana Trench sits on a tectonic plate boundary. Could a nuclear explosion here trigger massive seismic activity? Again, unlikely. The energy from our explosion would mostly be absorbed by the water and dissipated. To put it in perspective, the Earth experiences earthquakes of similar energy levels multiple times a year without setting off a chain reaction of disasters. Compared to the natural tectonic shifts that already occur, even the largest human-made explosion is insignificant. And the idea that this could throw Earth off its orbit? Impossible. Our explosion doesn't remove or add mass to the planet. It just redistributes energy. Plus, humans have conducted over 1,000 nuclear tests since the 1940s, and none have affected the Earth's path around the sun. So what's left? The fallout. The detonation would generate a cloud of radioactive material, some of which would mix with the ocean. However, water is incredibly good at dispersing radioactive particles, so most of it would be diluted before reaching any coastlines. Some radioactive material would escape into the atmosphere and fall back down as rain, but its impact would be relatively minor compared to historical nuclear tests. In the end, despite the power of our weapon, Earth shrugs it off. The Mariana Trench absorbs the blast, the ocean carries away the radiation, and life on the surface continues as usual. So what happens if we detonate a nuclear bomb at the deepest point in the ocean? Not much. Our biggest explosions are barely noticeable on a planetary scale. Nature's forces, tectonic activity, ocean currents, and gravity, are far more powerful than anything we can unleash. And in the grand scheme of things, our attempts to shake the planet barely make a ripple. Life is full of mysteries and hypotheticals, but one thing is clear: the universe is far more resilient than we give it credit for. Thanks for watching, and remember, some questions are best left unanswered.